Greetings of the day. Welcome to the course on Operations Research Technique. Students, you are aware that in earlier lectures we have covered in this particular unit 6 problems related to Monte Carlo simulation technique in variety of applications. Today also, to begin with this lecture, we will see one of the important application of Monte Carlo simulation technique in accounting business. We know in accounting basically two terms are involved. One is receipt and another is payment. So receipt of cash and payment of cash, and then based on that in a ledger we find what is the balance. This particular aspect is used in accounting business firms and also in banks. So we'll try to simulate the given data in the problem with the help of Monte Carlo simulation technique. You must be knowing now the various steps for solving any numerical with the help of Monte Carlo simulation technique. So to brief once again, we have seen that what is the essential part of Monte Carlo simulation technique is we will be given with the data of probability distribution corresponding to the parameters. Based on the values of probability distribution, we are supposed to find cumulative probability, that is step number 2. Then from cumulative probability, we have seen that we have to fix a random number range, and then we have to use either given set of random number and or the random numbers from standard data sheet. And then what we did in previous examples is we have seen in which particular random number range the given sequential random number lies, and then correspondingly the parameter of interest was taken which corresponds to the random number of given range. So now let's see the problem. So these are the steps. We have discussed these slides in earlier lecture also, and just now I have briefed what is to be done as a step in this particular slide. Now this is the problem pertaining to the area of accounts. You can see the terminologies involved. And the involved terminologies are, the problem states that, what is the definition that we'll read first? A small retailer has studied the weekly receipt. Weekly, important term is receipt, and another term is payment. So over the past, this data is for the past 200 weeks. So statistical data based on last 200 weeks has developed following information. So the information pertaining to weekly receipts, information pertaining to weekly payments in the form of probability distribution, which is obtained from this previous 200 weeks data. For our understanding, we are not interested in the figure of 200. This 200 weeks accumulated data is portrayed in this particular table, where we are given with the values of weekly receipts and weekly payments. Now receipt is gain. It is the amount received by the cashier, and payment is the amount paid to the customer by the cashier. So we should know the clear-cut distinction between receipt and payment. Receipt is receiving cash from the customer, and payment is paying back cash to the customer. Suppose in bank transaction, if I am going to deposit some money in my saving bank account, so that will be treated as a receipt. And suppose I go in bank for withdrawal of the amount from my saving bank, it will be payment term in bank transaction. So probability distribution is given for different amount of receipts as well as payments. Now you can see again here, if you sum this individual probability distribution, it will end with 1. And many a times I have said that cumulative probability is 1. Many a times I use this sentence, cumulative probability is 1, and in percent it is 100%. Now what is asked in the problem? Using the following set of random number. Again, students, set of random numbers to be used for this particular problem is mentioned here, and simulate the weekly pattern for receipt and payment for 12 weeks. Now from this week ahead, what is asked? From this week ahead you have to simulate the data for next 12 weeks. You have to simulate the data for next 12 weeks starting from 0th point. Means starting at 0th period will be our opening balance whatever given in the problem, and then we have to simulate the data for next coming 12 weeks, that is week 1, week 2, week 3 up to week 12. What is given? Assuming that beginning balance is rupees 8,000. This is very important, very important. So in this problem it is given that when we start at 0th week without any transaction of receipt and payment, at 0th week the amount available with cashier, we will say cashier or other department who is dealing with this business, is rupees 8,000. That is given, and it is nothing but in the language of accounts it is opening balance. In the language of account, this is opening balance. Now students, what is asked? That is important. Let's see what is asked. What is the estimated balance at the end of 12-week period? This is first thing that asked. You are supposed to find the estimated balance at the end of 12-week period. So we will be simulating data for 12 week, and then based on your present opening balance at the 0th week, which is 8,000, then transaction in every week in terms of receipt and in terms of payments, we will be having balance remaining at the end of every week, that is at the end of first week, second week, third week, fourth week. Likewise, we have to estimate what is the balance at the end of 12 weeks. That is one thing we will find through Monte Carlo simulation. Second, what is the highest balance for the quarter? 1/4. We know quarter is 1/4. So in particular we will see what is the highest balance, weekly balance. Third, what is given? The random number to be used. Now you can see here you are given 12 set of random number. This is random number 1. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 random numbers are given because you have to simulate for 12 weeks. Now since the random numbers are given for receipt, in my early lecture, depending on the number of parameters to be evaluated, for every case your set of random number will vary. The random number set will not remain same. Remember one thing, that whatever random number set available for receipt will not be the same for payment, because receipt is one other activity and payment is different activity than receipt. Therefore the set of random number will be different if it is given. Suppose in this example this data is not provided to you, random numbers is not provided to you, then what to do? It's very simple. I have also explained this concept. What to do? Just recall the random number data sheet which I have given in earlier lecture, wherein I have stated that you have to use random number in order of consecutive numbers column wise. So there, from those sheet, what we will do? We will take from any column randomly 12 vertically top to bottom one set of random number involving 10 numbers in sequence from one column, which will be for receipt. Similarly, randomly we will select from other column 12 random numbers in series. When you are supposed to carry this act, which just I have narrated, when set of random number is not given. When set of random number is not given. Now, students, to proceed for this problem, what is the important data that is available with us is this figure of 8,000, which is opening balance at the 0th week, and then this table. Now you know how to proceed. From this, what we will do? We will first, what we will do? Just recall. Yes. If your answer is, sir, we will go for cumulative probability calculation value from this probability distribution, you are right. So let's move ahead. Now you can see this table, and as did in previous problem, what we are supposed to do? For this suppose if we wish to calculate the cumulative probability, again what we are supposed to do? Weekly receipt, then we are having value of probability, then from this we will find cumulative probability. For this is for, I will mark here by other line, a differentiation line. This will be for this receipt purpose. Similarly, for payment purpose, what we will do? We will do weekly payment, then we will go for probability given, and then we will go for cumulative probability. Again I will recall my sentence which I have used in previous lecture, and the sentence which I have used was that the nature of the table for calculation will not same for all problem. It will vary as per demand of the problem, but basic logic will remain same. So now if you go for these values as given here, 3,000, 5,000, then 7,000, 12,000, here it is 4,000, 6,000, 8,000 and 10,000. These are the values given with probability 0.2, 0.3, 0.4, 0.1. Here it is given as 0.3, 0.4, 0.2 and 0.1. Clear? Now you know the task to be performed. Cumulative probability. Can you just guess? Very simple. Yes, it is 0.2. Then what I did yesterday, you know, add further probability in previous cumulative probability. So it will be 0.2 plus 0.3, it will be 0.5. For further value, 0.5 plus 0.4, 0.9, 0.9 plus 0.1, 1. So whenever you find cumulative probability, yesterday we have seen that ends with 1 always. Now here for this case it is again 0.3. Clear? 0.3 plus 0.4, it is 0.7. Okay, then 0.7 plus 0.2, it's 0.9, and 0.9 plus 1, it is 1. So student, this is the step number 2 as per given in Monte Carlo simulation technique. Now what is required is, our task is to find the random number range, and for that what we are supposed to do, we have to add one more column after this, one more column after this. Now this is 0.2, so I will explain the range for this 0.2 and 0.3. Now for 0.3, keep this figure in mind, 0.2. How to find range for 0.2? Yesterday I have explained the concept. Multiply this 0.2 by, suppose I make it by, multiply by 100, I get the number 20. I get the number 20. Now for finding range of this first row, what I said yesterday, the range of random number will be one number prior to that higher side. So higher side will be 19 and starting will be 0. So 0 to 19 will be the first number. Second, it is 50. So 20 to 49 will be the second. Then 50 to 89 will be the third range, and 90 to 99 will be the third range. These are the range of random numbers for this cumulative distribution. Similarly, for this, if you multiply 0.3 by 100, you will get 30. So first range will be 0 to 29 for this. Second will be 30 to 69. Then 70 to 89, and last will be 90 to 99. So here, for your understanding, I have written. We'll see this in detail in next slide. Only to have clarity that how range will be calculated, I have explained already. I have calculated the range for you people. So you can see here, my intention was in previous slide was to tell you the actual calculation. So this data was given to us. Based on this data, as discussed in previous slide, we have calculated this particular range. This particular range, here we are calculated this particular range. So the range states 1 to 19, because it is maximum 20, so one number prior to that, 1 to 19, like that. Here 30, 1 to 29, like that. Now this column is very important. Similarly, this column is very important, because what we have to go in calculation now is, we are given set of random number, we are provided with random number for receipt, we are given random number for receipt, we are also given random number for payment. We are given these two values, random number for receipt and random number for payment. Clear? So 12 values are given to us. We are provided with 12 values. So our task in next calculation will be to find where that particular random number in given order falls in which random number range. And suppose the random number falls in that particular random number range, then we will focus our point to corresponding receipt or payment. We will focus our point to corresponding receipt and payment, and then we will start from big number 0 with initial balance. If you recall, it is given in the problem that initial opening balance is rupees 8,000. So when I am starting my transaction at the end of first week, initial balance is 8,000, and it depends on receipt and payment. At the end of every week my balance will be varying. So let's see further part. So here the entire problem is solved. I will explain the concept. Now we have selected the random. This is the set of random number given. Receipt random number set is given in order. As I have said, for week 0, important is this is 8,000 opening balance. For week number 0, 8,000 opening balance. You can see here there is no receipt in first week, there is no payment in first week. Very important. So when you start simulation for such type of problem with amount of opening balance given, you have to start from 0 week and simulate it for corresponding 12 weeks. You can see here this is 12 weeks. This is 12 weeks in order, and what we did is we have written this random number in the order given. Now where come from this figure of 3,000 come, where from this payment 6,000 came? That may be question in your mind. So for 3 remember figure 3,000. For 61 remember figure 6,000. 3,000, 61, 6,000, and we will check how we have arrived at this value of 3 corresponding 3,000, 61 corresponding 6,000. Then in the similar fashion you will get idea that the logic which we have used for this first row is followed for other rows, other weeks from 2nd to 12. Just remember the number 3, 3,000, 61, 6,000. We'll go back. So 3, I will write 3,000. For 3 it was 3,000. For 61 it was 6,000. We have witnessed that is written in that slide. Let's check how. Now this is random number. Similarly this is also random number, and this is receipt value, and if you recall this is payment value from last previous slide which we have just seen. Now what is important, we want to check how we got the value 3,000. See here random number 3. Now for receipt, let's divide this into two parts to avoid confusion. So left part talks of receipt, right part portrays payment. Now we are focusing our attention on the value of receipt. See here we have to check left hand side of this table. See where this random number 3 lies. So here in this random number range 1 to 90, these 3 lies. So I will do the same pattern as we did yesterday. So this is the row for this random number 3. Now its location is decided, it is first row, and for this same, see here you can add column over here also, or this is the value pertaining to first row, and for first row it is 3,000. It is 3,000 for the same probability. So that is the reason why we chose the value as 3000. I think explanation is clear. Clear? Yes or no? Similarly, now for payment, what we'll do? We'll look for right hand side table, wherein this payment we'll see the number 61. We'll see the number 61, and 61 number lies in the second row. Here 30 and 69. So this number 61 lies in second row. And for second row in payment, you can see the value is 6000. For second row, the value is 6000, and therefore students, we have taken this Therefore, we have taken this 6000. So I have explained through example of given random number how to find the value of receipt and payment for that corresponding random number. Same thing you have to perform for what? 12 remaining 11 random number. Same thing, same process. And you can see here that by adopting the same procedure, we have evaluated all values from 3000 to 5000 for receipt. Similarly, we have evaluated these values for payment. Similarly, we have evaluated these values for payment. Now, very important, focus your attention towards board. See, for finding value for end of week 1, initial balance was 8000. Of course, here the unit is rupees. Initial balance before first week was 8000. Your receipt is 3000. Means you have received. Receipt means you have received 3000. So 8000 earlier, you have received 3000. So now at this point, total amount with you is 11,000 at this point. But at the same time, you paid 6,000. So see, first your opening balance was 8,000. You have received 3,000. So your total became 11,000. At this point. Of this, you paid 6,000. Therefore you have to subtract. Here addition side is for receipt and this subtraction side is for payment. Got it? So what will be the balance at the end of first week? 11,000 minus, so it will be rupees 5,000. So see here, I have calculated and written the value of 5,000, which is visible to you. Got it? Now we have to follow the same logic. Now as we have used the criteria of 8,000, Now for subsequent weeks, this 8,000 figure will not come into picture. For second week, the balance at the end of first week will be considered. For third week, balance at the end of second week will be considered. Likewise, for 11th, balance at the end of 10th week. For 12th, balance at the end of 11th week will be considered. Got it? Let's move ahead. Now here, if you recall, see here, the balance is 5,000. Now, if we want to evaluate for week number 2, opening balance is 5,000. Opening balance is 5,000. 5,000 is the opening balance. I am talking of week 2. For week 2, we are calculating for week 2. 5,000 was the opening balance plus for 2, see here the receipt amount is 12,000. So net cash at the end of second week with you is here it is 17,000, but focus on this figure, it is 10,000. So payment, so minus 10,000, so it comes to be 7,000. And see here what we have written, it is 700 000 7 1 2 3 000 7,000. So likewise, this is I have explained for first row, this is for second row. Now likewise different values are calculated. Now let's see what will happen at the end of 12th week. For 12th week, we can see opening balance is 2,000. I am talking of 12th week. 12th week opening balance is 2,000, which is the balance at the end of 11th week. Then see, receipt is 5,000. So you are having plus 7,000, but payment was 10,000. So the balance is minus 3,000. So that is in deficit. That is in deficit. So you have to mention what is the criteria. So at the end of, as asked in the problem, depending on the value of random number, if somebody select different sets of random number for this, definitely this value will not be same. It will vary as per the random number selection. For this set, we are coming with this value. Now at the end of 12th week, the amount is deficit. Since the sign is minus sign, we are writing it's a deficit, minus deficit by 3,000 rupees. That is the answer for first part. Now at the end of second and fourth week, the balance is highest, that is of rupees 7,000. So see the balance sheet. In this balance sheet, highlight the highest value. Highlight the highest value. Here 5,000, second is 7,000. Then highest again, this is 7,000. So this particular calculation of balance indicates that at end of second week and at the end of fourth week, the balance is highest. Now one thing you have to keep in mind here, what we did is we have solved this particular problem by manual method. Why I am saying manual method? Because we have taken only limited, restricted values of random number, and that too we took 12 random number for receipt, 12 random number for payment. But in real life, this is not performed with this is for our understanding purpose. When we write computer program for simulation, logic will be same, logic will be exactly same which we have used in this problem when we write the program, computer program for simulation, or when simulation program, simulation software is prepared, same logic will be used. But students, in real life, this is solved with the help of sophisticated computers. We are taking help of sophisticated computers, and for that we take a large number of random numbers. And when we take large number of random number and we take simulated result of those large number of random number, definitely we are minimizing error and our accuracy is enhanced. Our results are close to the reality. So remember one thing, in real life all simulations problem are solved with the help of computer software. That point you have to keep in mind. Now with this we finish with the topic of simulation. Now in the same unit, if you know, I have given in introduction that we are having other unit referred as queuing theory, or other name of this queuing theory is, you must know that other name in the language of OR for decision making, the other name is, in many book you will find waiting line models. And students, this is the widely used tool of operations research in case of decision making. In day-to-day life, in all corners, in all working areas, wherever we go, we always come across with this term, that is queue. We always come across the term called as queue, and from queue the term is queuing. From queue the term is queuing, or other synonym of the same queuing theory or queuing models is waiting line model. We are familiar with the term as a individual, we are familiar with the term queue, as well as we are familiar with the term wait. I am focusing my attention on the word wait. There are so many situations in our life, in our day-to-day business, that we are required to wait. Particularly when we are interested in getting some service at related facility provider, we come across with the concept of wait. We as an individual, we are interested in getting service. Many numerous types of services that we'll discuss when we'll progress in this particular topic. Variety of services are available or required for human being to be performed, and there are service providers. And the important terminologies or terms related to this aspect is, one is service provider, that is facilitator, and one is the person, individual who want to take service. who want to take service as a customer, say, as a customer, and other party is service provider. So there it is depending on the relationship, some mathematical relationship. Queues are formed. Queues are formed, and since queues are formed, long waiting lines are generated, long waiting lines are created. And we know, as a human being, we lose our patience, temperament when we are supposed to wait in the queue or waiting line for a very, very long period. We get frustrated as an individual, and we start blaming the system that they should provide more number of service facility to reduce the waiting time. But students, keep one thing in mind. In operations research, what we aim is to optimize the things. Suppose instead of one service provider, I deploy 10 service providers. In that case, service will be definitely very fast. But as a service provider, I will expend a lot of money as a payment to the persons who are giving me service. Unnecessarily, I will increase my burden and my profit will be reduced. So, as a tool of operations research, what is required is you have to have optimum service facility in your business so that waiting time of the customer is reduced, waiting time of the service taker is reduced. That is very important. And remember one thing, queue is inevitable part of human life. Everywhere you go, you will find queue. And the population means you and me who are living in this universe are bound to obey the rules pertaining to the queue for effective working of the queuing system. If we do not cooperate, then we have seen many a times collapse in the queuing system. Therefore, technical contents are provided in the queuing system so that the queuing system becomes foolproof with optimum number of service providers for particular service and maintaining minimum time for the service with minimum cost to the customer. Got it? So one important thing which I have quoted, queuing is or waiting line is inevitable part of your life. Wherever you go, you are coming across formation of queues. You cannot avoid queues, and if you try to avoid queues, you will be blamed, you will be boycotted, you will be it will be considered that you are disturbing the system. So let's see the inputs in that. A queue in general is formed at any place as explained by me when a customer, a human being or physical entities. Now here the meaning is a customer can be a human being like you and me or physical entities. Means in manufacturing scenario, the material waiting in for being processed material, being or in waiting for being processed, or machines in waiting for maintenance. That logic is related as physical entities that require service. Again we'll read, a queue in general is formed at any place when a customer, that is human beings or physical entities that requires a service is made to wait due to the fact that number of customers exceeds. Important terminology, important point I will first highlight. Number of customer exceeds the number of service facility. So two things very important as discussed in queuing. One is customer and other service facility. Customer and service facility. If there is improper balance between these two things, or when other reason or when service facilities do not work efficiently, important again, service facility do not work efficiently and take more time than prescribed to serve a customer. So these 5 sentences which are written over here are very, very important to understand the logic why queues are formed in real life. So first we have quoted number of customers exceeds the number of service facility, that is one reason. Second, service facility are not working efficiently. They are there, service facilities are there, but they are very casual. They are not taking cognizance of the customer who are to be served in right manner. That is the reason why queuing theory is formed. So what we'll do, we'll stop this today's lecture at this point of time, and from next lecture we'll see the details of this queuing theory with numericals. So till that, practice the problems pertaining to simulation and imagine what are the scenario where we come across queuing theory. So further part we will see in next lecture.